Assalamualaikum warahmatullahi wabarakatuh. So today we would like to present our final project of microprocessor and IoT. My name is Ryandhita Arrifqi and here's the member.
My name is Robby Putra Sigit.
I am Azka Abdurrahman Rizki.
And I am Narendra Maharddhika.
I am Dewa Wedagama.
Yeah, and that's all the members. So here's our presentation.
So for the tools and materials, we use a Node MCU like this. So basically Node MCU is open source platform for the IoT. And then the second one, we have USB cable for the connector. And then the third one, we has jumper cable, which is a connector from Node MCU to DHT11. And then the next one, this is a DHT11, is to measure of a temperature and humidity. And the next one, for the cloud, we use Blink Console. So Blink Console actually is a web application that acts as the central hub for managing IoT project within the Blink platform. And then the last one, from the application, we use Arduino IDE. So basically, Arduino IDE is a free software for writing programs that run on Arduino boards. So that's it for the tools and materials.
So for the Node MCU and for the DHT sensor to work, we can use the Arduino IDE to run the code or the programming. So this coding here or this program is actually taken from one of the examples from Adafruit. So this is where the initial setup happens. As you can see here, this is where the library is imported. And this line here defines the pin of where the DHT sensor is connected to the Node MCU. For our case here, we actually connected to the D2 pin. And the type of sensor that we're using right now is actually the DHT11. So I'm going to comment this out and bring this back. And we have to make sure that the baud rate here is 112,500. And as mentioned by my colleague previously, the DHT sensor is for monitoring and detecting the temperature and humidity of the surrounding area of the sensor. So all of this code and programming here is used to make it happen. Now all that's left to do is to upload this code into the Node MCU. And also, we must make sure before we upload it, we must make sure that the Arduino IDE and the Node MCU are connected through this thing here. So here's Node MCU1 and it's connected through port USB COM9. Now, all that's left to do is upload. So as we can see from the bottom of the screen, the program is successfully being uploaded. And when it's done uploading, we should be able to monitor the temperature of my surroundings as well as the humidity through the serial monitor. As you can see, it's done uploading. All we need to do is open the serial monitor. And as you can see here, let me zoom in. There we go. We can now track or monitor the temperature and the humidity. And in my surroundings, it seems the temperature is 29.3 degrees Celsius and the humidity is at 60%. However, now I would like to try to blow my breath into the sensor and see if the humidity or the temperature increases. So I just blew my breath into the sensor. Now we should expect an increase in the humidity especially. So as we can see, at the beginning it was at 60% and now it is at 83%. So this is an indicator that the sensor works correctly. And also the temperature, as we can see, has increased only a bit by 1 degree Celsius. But that's how we can know that the sensor is working well and the Node MCU as well. And that's it for my part. Thank you very much.
Okay, so in this part, I will explain how to send the data to the Blink platform for remote monitoring. So first, is we include the necessary libraries to perform data transfer to the Blink platform. In this case, there are three, which is dht.h, ESP826655.h, and Blink Simple ESP8266.h. The DHT.h library allows us to interface with the DHT11 sensor, while the ESP8266 Wi-Fi.h provides Wi-Fi functionalities for the ESP8266, and Blink Simple ESP8266.h library integrates the Blink with the ESP8266. Next is we define some constants and initialize objects, which is the Blink templates underscore ID, Blink template underscore name, Blink out underscore token, and Blink underscore print serial. Now, these are Blink underscore template and Blink underscore template underscore name are identifiers for the Blink project template. While the Blink token, this authenticates our device with the Blink server. While the Blink print serial, this directs Blink's debug prints to the serial monitor. Next, we also define the pin and the type for the DHT sensors and create an instance of the DHT sensor, which is the DHT pin D2, which means the pin on the ESP8266 connected to the DHT11 data pin. The DHT type is the type of DHT sensor used, which is DHT11. Next, we define the Wi-Fi credentials, and in this case, the SSID name of the Wi-Fi network is A, and the password is Dikagantong. And next is we configure the blink timer and virtual pins. The blink timer initialize a timer object for periodic task. And the next one is the following functions that handles the virtual pin V0, which is the blink write V0 means that this function is called whenever a value is written to virtual pin V0 in the blink app, while the integer value equals to param dot as integers reads the value sent to from the blink app, while this code writes the received value to virtual pin V1. The next function sets the properties for virtual pin V3 when the device connects to the blink. So Blink connected means that this function is called when the device connects to the Blink server, while the Blink set property v3 set properties for virtual pin v3 including off and on image URL and a link to a web page. The next function is periodically by the timer, which means that, for example, this is Blink virtual write v2. It means that writes the uptime in seconds to virtual pin v2, while my timer event means that it sends the device uptime in seconds to virtual pin v2 every seconds. Next is the setup functions we use to initialize the DHT sensor, serial communications, and the blink. The first one is the dht.begin, which serves the purpose to initialize the DHT sensor. The next part is the serial begin 9600, which starts the serial communications at 9600 baud rate. The next one is the blink.begin, which connects the blink using authentications token and Wi-Fi credential. And the last is the timer.setInterval, which setups a timer to call my timer event function every second. The last function is the the loop function, which used to handle reading sensor data and running blink. The delay 5000s introduce a delay of 5 seconds to control the frequency of sensor readings. The blink run keeps the blink connections alive, handling all blinks related data. Timer.run execute timer functions such as calling my timer events functions. The hum equals to dht.read humidity serves as to read the humidity value from the DHT11 sensor. The temp equals to dht.read temperature reads the temperature value from the DHT11 sensor. while the blink virtual write sends the temperature reading to virtual pin V0 on the blink app. And the last is blink virtual write, which sends the humidity reading to virtual pin V1 on the blink app. That's all. And the next part will be explained by my friend.
To sending to the cloud, we must connect Blink with Arduino IDE. Before that, we must set up our device in Blink, which is the template. You can add the new template, and after that, we choose ESP8266 and we follow it because we already made the template. This is the name of node MCU. The temperature is on V0 and the humidity at V1. Because we already made, we can directly to device. In here, make sure your device is online. To know your device is online, you need to upload the code that already made, and after that we running it, and after that your device is online and your device is already to sending data to here to the cloud. For connect Arduino IDE with the Blink or the cloud, you need to set up the code, which is when you already made the device on Blink, the template ID, name, and token, it will be appear automatically in here, usually in near here, and then you copy it to Arduino IDE, which is this is our token and this is our template name, this is our template ID, and we also set up the Wi-Fi. We must connect it in one Wi-Fi. This is our Wi-Fi, and yeah, your device is ready to sending the data to here. We also made the cloud to the phone, which is in here. The data still the same. Let's try to the material and tools. Let's try to blow off. Let's see it work or not. Wait. See, the humidity is changing, and we already do simulate from 320, which is this is the historical of the temperature until now 341, and this is for the humidity from 329 until 342. It changes every single time when humidity and temperature change. I think that's it. Yeah, I think that's all from our group. More or less we apologize. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.